Alright, so today we are going to be analyzing congruent triangles and practicing using some of the postulates that you learned yesterday. If you need to, take a minute and review all of those different ones that we took notes on yesterday before continuing on. Here are several examples to help get you started. In this activity, you want to identify the method that each of these triangles can be proven congruent by. In other words, name the postulate that we learned yesterday for how you could prove each pair of triangles is congruent in exercises A through I. So let's look at A together. If we have one side here, which is congruent to this side over here, then we have this angle here and this angle here that are congruent, and we have another side here and a side here that are congruent. So by side, angle, side, those two triangles are congruent. Remember that when you have several angles that are labeled as congruent, here we don't know anything about the sides. We just have three sets of congruent angles. Okay? So the postulate that we have for that is simply angle, angle. Moving on to the next one. This one, we know that two sides are congruent, here and here, and that two sides are congruent here and here. And we also know that there is an angle that is congruent right over here. However, we have an angle and a side, and we know that there is no such thing as SSA as a postulate. So what we need to figure out is how we can determine that these two triangles are congruent. Notice that the two angles that we were told were congruent over here, that they were both right angles. So look back at your postulates from yesterday and we will see that there are two different ones that we talked about with right angles. The hypotenuse and the leg being congruent, and then there was a leg and an angle and a hypotenuse and an angle that we talked about. In this case, we have this hypotenuse and this hypotenuse that are congruent, and we have this leg is congruent to that leg. So these two triangles are congruent by the hypotenuse leg postulate. Okay. Moving right along into option D, we see that there are several sides and angles labeled as congruent. We have an angle here with this angle here. We have an angle over here with this angle over here. And we have these two sides are congruent. So we have two angles, which means we have angle, angle, and then we have a side. So angle, angle, side, or AAS, would be the postulate that proves those two congruent. In E, we know nothing about the angles. So what do we know? We have a side and a side. Then we have this side congruent to this side. And since they share a side across the middle, we have that side is congruent as well. So by the side, side, side postulate, we know that those two triangles are congruent. Take a minute and look through F, G, H, and I and see if you can figure them out yourself. Alright, so how did we do? In F, you should have had SAS for side, angle, side. And in G, you could have had side, angle, side, or used one of the right triangle postulates. Side, angle, side is probably the more common one, though. And for H, you should have had angle, angle, side as the postulate that proves those two triangles are congruent. Now, let's look at I. Remember, we don't have a side-side angle postulate, and all that we are given as congruent are these two sides along with these two sides and this angle over here. So if we can't prove them congruent by side-side angle, because that doesn't exist, and these are not right angles, then we should come to the conclusion that none of our methods will prove that those are congruent. So you cannot determine that those two triangles are congruent based on the given information. Alright, so we're moving on to a different set of exercises. This one wants you to name the additional equal corresponding parts needed to prove that the triangles are congruent. So it gives you which postulate or theorem it wants you to prove it with, and we have to determine each of these congruence statements. So for A, we are given that C and F are congruent angles, A and D are congruent angles, and since we want to prove by angle, angle, side, then we need a side that is congruent. So you could use BC and EF as congruent angles, or congruent sides, I'm sorry. So that would make it angle, 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 and angle. So when you go around here, let's put those two back up there like they were. So when we go around, we have angle, angle, side, angle, angle, side. You could also say that if you wanted, AB and DE are congruent. So then we come the opposite direction and we say angle, angle, side, angle, angle, side. Okay? So go ahead and try this next one by yourself. We should have by the hypotenuse leg theorem. These two triangles are congruent. So what needs to be said about each of these? Alright, so you should have had time to go through and prove each of these, what you needed to say about angles or sides that makes each of these triangles congruent. So by the hypotenuse leg theorem, we have to use GI equals JL so that we have a hypotenuse and a leg and a hypotenuse and a leg. Okay? In each of the following ones, by side angle side, we have to have, in this case, we have one angle. So we have to have two sides are congruent. So MO equals PO and NO is equal to RO in order for this to be true. The same goes for D. We have to have TU equals WX and SU equals VX, because we only are given one side here, and we have to find out that these two are congruent and these two are congruent. Okay? In E, it's the same thing, except by ASA, we have to give two angles that are congruent. So the measure of angle T equals the measure of angle E. T and E are congruent. And TOW equals EON. So here and here. And if you'll remember from back when we talked about parallel lines being cut by a transversal, we talked about vertical angles and how they were always congruent. Here we have two vertical angles, so we have to know that those two are congruent. And finally, we have by leg angle, so a leg here or a leg here and an angle here, then we can say IX equals en, or Sx equals Tn. In this case, we don't have to have both. Alright, so hopefully this has been helpful for you in practicing with several different types of examples. I want you to complete the rest of the exercises on this page and bring it with you to class so that we can discuss them.